Welcome to our Chapter 7 Nutrition Textbook Lecture titled Marketable Food, Growing, Handling, Processing, and Packaging. In this chapter, we will learn the difference between organic, certified organic, and conventional production of food. We will be defining genetically modified organism and agricultural biotechnology. We will talk about how food is harvested and transported, and learn about food additives, food irradiation, freeze driving, and sous vide. We will also be identifying the characteristics of enriched and fortified foods and their roles in nutrition. Lastly, we will define processed food and processed packaged food and nutritional differences among the various types of processed food. When talking about consumer interest in food production, there have been a lot of changes in the last 10 years. Consumers are more interested in sustainability, the use of organic food, and getting food from local sources. This goes for chefs as well as consumers. Just thinking of how much more common farm to table has become, we can see how this is becoming a top food trend. The challenge is for food service operations to meet the demand for purchasing local and still receive the quality and variety needed at an affordable price. Farming methods are changing and evolving with a goal of achieving sustainability. The Environmental Protection Agency defines sustainability as practices that meet current resource needs without compromising the ability to meet future needs. This requires innovation in order to maintain quality and to increase supply without damaging the environment or consuming valuable resources. Supporting farmers and businesses that produce food is extremely important. Food is grown for profit, and without financial success, not only will there be a lack of an incentive to produce food, a farmer might not be able to keep a business running efficiently. And I think it's fairly ironic. Our food trends continue to push more and more to nutrition, farm to table, overall healthy eating, but we're seeing fewer farms, and it's increasingly difficult for farmers to stay financially sound. Food service operations often rely on conventional food products, which are food products grown using approved agricultural methods. In the U.S., these methods are studied and regulated by the USDA. The approved methods allow for the use of certain fertilizers, pesticides, herbicides, hormones, and medicines that are deemed safe. The majority of foods sold by supermarkets come from conventional producers. Organic food is food that has been produced without synthetic fertilizers, sewage sludge, irradiation, and genetic engineering. In USDA terms, if a product is labeled organic, it has been produced through approved methods that integrate cultural, biological, and mechanical practices that foster cycling of resources, promote ecological balance, and conserve biodiversity. If an animal has been raised organically, it has been given organic feed and access to the outdoors, and it hasn't been given hormones or antibiotics. If farmers wish to have their food labeled certified organic, they must submit a plan for their operation outlining specific practices, substances used in production, how they separate non-organic from organic, their record-keeping methods, and a commitment to allow inspections. They must also pay fees to support this process. But if a farm sells less than $5,000 worth of organic, they are exempt from the certification, and they can label the product organic, but just not use the organic seal. Now, moving on to genetically modified food. Genetically modified foods have been a huge debate, but let's talk a little bit about what is actually included in these. First, we have traditional crossbreeding, where different varieties of plants or animals are bred to produce offspring with the best qualities of each variety. Hybrid plants are an example of crossbreeding. Genetically modified organisms are plants or animals whose genetic makeup has been altered using recombinant DNA technology. So this technology allows two organisms to be combined and the change to be permanent to the genetic code of the receiving plant or animal and is its offspring as well. These genetic modifications are done by scientists, and there are multiple reasons that scientists may choose to modify the organism genetically. They may be trying to produce a plant that can resist pests, weeds, or chemicals that will kill pests, or they might be trying to enhance the nutritional value. Genetically engineered animals could have new traits that will allow them to grow faster or be more disease resistant or to live in areas where they weren't able to thrive before. So what has made people uncomfortable with GMOs? Consumers worry about the long-term environmental and health effects, and some are concerned that the product could contain a gene from another organism that they could be allergic to. And some feel that there could be a moral issue to it. This has been a worldwide debate, and some countries don't even allow them in food at all. So now our food has been grown and it's ready to harvest and transport. Even though growing, harvesting, and transporting is out of our control in the food service industry, how it is all done and accomplished really impacts us. We're looking for food that is harvested at its nutrient peak and in its best overall condition. The goal for food producers and processors at this stage is to preserve the quality that it remains safe to eat and continues to be nutritionally rich as it travels. After harvesting, washing, trimming, cutting, and some preservation is often necessary. At each stage of handling, food has some nutrient loss. For example, a physical loss is caused by removing the tough fiber and vitamin-rich stems of broccoli when packaging frozen florets. There may be a chemical loss of nutrients in canned or frozen food. The longer fruit and vegetables are allowed to grow until ripe, and the sooner it is eaten after harvest, the more nutritious it will be. Exposure to sunlight, heat, and oxygen during long periods of storage will contribute to more nutrient loss. In order to receive the food, it must be transported. Sometimes this requires different forms of transportation. The textbook uses the example of fresh raspberries from Chile. They might have been carried by hand in the field, on a wagon to the farm's processing center, taken by a truck to the nearest airfield, and then flown to their final destination. From the airplane, they are driven to a local distributor and then taken to the grocery store, restaurant, or food service operation. When purchasing local product, there is less loss of quality or nutrients. The product does not have far to travel, so it can grow for a longer period of time. Sometimes, as much as we would love to serve or use fresh product, it might be that it's just not available or it's too expensive. That, without a doubt, is something we are experiencing right now with the rise in food cost. Freezing, canning, drying, or juicing can be an alternative food method and still contribute significant nutrients and meet nutrient needs. Processed food is food that has undergone any type of planned or deliberate change before being delivered for consumption. This is any processing from minimal to complex. An example of minimally processed food is washed produce stored in a clean package. Processing further to frozen food, canned food, jar baby food would be considered packaged processed food. Items such as mixes made at home where the consumer processes the product further also is under packaged food. Food might be processed to preserve it for transportation. For example, produce being washed and packaged to delay deterioration. Food additives are ingredients that are put into the food to perform specific functions, like improving flavor, color, or texture, retaining nutritional value, preventing spoilage, and extending shelf life. Some additives are simple, like vitamin C to prevent browning, but others might be chemicals like fillers, binders, colors, and preservatives. This chart shows various food additives and their functions. It's important to be aware of these, and they can change the original food and the reception by consumers. A few different processing methods are food irradiation, freeze drying, and sous vide. With food irradiation, food is treated with ionizing radiation, which reduces or eliminates the bacteria and parasites that cause foodborne illness. It also inhibits sprouting and mold growth. It does not change the nutritional value of food and does not make the food radioactive or dangerous to eat. When food is freeze-dried, all moisture is removed to prevent it from spoiling. A machine first freezes the food, then the air pressure in the machine is lowered so that the ice changes into water vapor. When the food is dry, it is packaged into waterproof pouches. The food retains its nutrients, can be stored for a long time, and can be restored to its original form by adding water. With sous vide, food is vacuum packed and cooked slowly in a vacuum. In a restaurant, the food is served when it is cooked and ready, but in food manufacturing, the food is chilled or flash frozen when fully cooked. There is a risk of pathogen growth with this method, so it's important to monitor temperatures and follow HACCP guidelines. One thing we see on the baking side a lot is the term enriched. When flour is milled, the bran and germ are removed, leaving the endosperm and protein in white flour. It is versatile but lacks nutrition. When nutritional deficiency diseases were still common, the FDA adopted federal standards of identity for flour and initiated an enrichment program. Enrichment restores nutrients that are removed when food is processed. Flour is now enriched with thiamine, riboflavin, niacin, iron, and folic acid. Some foods are fortified with nutrients. Fortification is adding nutrients that the food did not have originally. We would see this with the addition of iodine and salt, calcium in orange juice, vitamin D in milk and cereal. These fortifications increase the value of food because they contribute nutrients that may otherwise be difficult to receive. Receiving and storing food can also change the nutritional value of food. When food has been received, it has already decreased in nutrients due to the process that it took to get there. When receiving the food, we want to make sure it is safe to consume upon entry. Frozen should still be frozen. Refrigerated items should be at least 41 degrees or lower. Dry goods should be at room temperature and be clean and dry. Fruits and vegetables should still be in good condition. When storing, maintain proper temperature for each type of food. The best way to prevent deterioration is to maintain a low inventory, so only order what you need. Thank you for listening to the Chapter 7 lecture. Please review the summary slides 14 through 26. After reading Chapter 7, please complete the Chapter 7 quiz and have a great week.